metal groups because we don't know their charges. So now we're going to talk about how we bond metals with nonmetals and ionic bonds when involving transition metals. So at the end of today, you're going to be able to name and write the formula for ionic compounds that involve transition metals. So what are those metals in the middle? Anybody remember what we call them? Yes, transition metals. And remember we said they have a varying amount of valence electrons. When we talked about valence electrons by group, we said it was 1 or 2, and it varied in our group of transition metals. So we need to know what we're dealing with in order to write the formula, because we have to have a charge in order to swap, drop, and chop. So in the name, you'll see a Roman numeral. And that is a way of notating which transition metal we're dealing with, all right? Is it cobalt 1? Is it cobalt 2? Which one are we dealing with? And so right here, for example, you see cobalt and then a Roman numeral 2. So that tells me the charge of cobalt is plus 2. All right? So here are your Roman numerals for the box to the right. Go ahead and write these down. Some of you have seen them in Latin class. Somebody told me they know them from Minecraft. So thankfully, these are not new to you.
Oh, yeah.
Enchanted.
All right. So how do you swap, drop, and chop with transition metals? So look right here. I have cobalt 2 chloride. So here's my cobalt. Here's the charge. Same exact thing we did, but hey, now the charge is given to you. You don't have to go thinking about how many did it lose, what did it gain, right? It's given to you. And then chloride, and you've got to find that charge just like we did before.
Do you write that down?
Yes, that's why it says cobalt 2 chloride as an example. All right, so right here you have cobalt 2 minus 1.
I told you.
And so we're swap, dropping, and chopping. Here's our swap. All right, drop the charges. And then do I need to write the 1?
No.
No, so CO, Cl2.
Boom. I'm insane.
Great job. All right, let's look at the next example. 10, like tin foil, not the number 10, tin foil. All right, 10 IV, and what does IV stand for?
4.
4. Yeah, so 10, it's got a positive 4 charge, and then oxide, and we know that oxide has to gain 2 electrons to get to 8, so it's a negative 2. So this is what you have when you split it up into ions. So step 1, we need to swap those charges. We need to drop the charges, get rid of our plus and minus.
And chop them.
Yes, and chop them. So what do I need to do in order to chop them?
Divide.
Divide by
2.
2. And so 2 divided by 2 is 1. All right, and 4 divided by 2 is 2. So SnO2 is what you end up with.
I'm crushing it.
I thought you just flipped into 2 on the other side of the formula. Why 2?
Can you divide by 2?
So yeah, we just simplified. They both least common factor. So both of them have 2 in
If
common.
that was a 3, you just flip them.
It's
Correct. You can't simplify it anymore. If it was a 2 and a 3, you can't simplify it. So then you would leave them. But since these can be simplified, I didn't move the 2 back there. Notice my 2 is still what color? Green. So it was still originally 4. It's a ratio. So look right here. It says think about like fractions. 2/4 is the same as 1/2. So instead of 2/4, we had 1/2. Baker.
So on the test, if we write 2/4,
It would be wrong. You need to simplify. Yes.
How do you tell the difference between positive and negative Roman numerals?
They will never be negative. Remember, that was a good question. In ionic bonds, what comes first? The metal. Yep, that was my next question. And it is the cation. All right, metals are always positive. Remember, T looks like a plus sign.
Cat has palms.
Yes, the cat have talls, like positive. All right, so metal cations, they're always positive. So positive comes first, negative comes second. That's your non-metal. Remember, N for non-metal, N for negative, or not plus. All right, so let's look at some examples. Copper oxide. Copper is, great job. What's our charge? Plus 2. And then oxide, which is
minus 2.
minus 2. and then we swap them and drop them.
So it's CUO.
CU, yep. Why is it CUO? Because my 2's cancel out. So no, that's that same example there of why the 2's go away. All I did was reduce them to 1's. All right, now let's look at silver chloride. Silver is Ag. What's my charge?
1.
Was 1. Chloride is -1. Yep, and so we're going to swap and drop.
AgCl.
AgCl. Do I need to write the 1's?
No.
No.
Crushing.
So, AgCl.
How
Great
come-
job.
Is that all?
That's not the full lesson, but that's for this part. That's going to name the formula.
That was easy.
Is the full lesson, did it end at covalent bonds? Do you have one more
Nope.
page?
It's just formula to name. The rest of this page.
Yes, we have this last page.
Yes. All right, so name the formula is pretty easy, right? Same exact thing we've been doing for 2 days. So now we're going to go formula to name. It's also easy, but we got to add a little bit of math in there. Because do we know which transition metal we're dealing with? Do I know the charge of it? No, but can I calculate it, do you think?
Yes.
Yes. All right, so remember, transition metals, their charges can change. So if you're dealing with, I'm going to flip back real quick. If you're dealing with AgCl and that's all you have, and you're like, you tell a scientist, oh, I have silver chloride, and you don't put the Roman numeral, do they know what silver you dealt with? No. All right, so you must have a Roman numeral in there. So we need to figure out what Roman numeral to put. So charges change since we know the overall compound must be neutral, right? I have a cation and an anion. And the amount of positivity in order to be neutral needs to equal the amount of negativity, yes. So that way we can always calculate the charge of our cation. So let's go over here and look. Here's your steps. Think transition metal. Transition starts with a T, yes. So we're going to draw a
T chart.
T chart. Transition metal, T chart. Those are your reminder keys there. And then oxide, which is -2. And then we swap them and drop them.
So it's CUO.
CU, yep. Why is it CUO? Because my 2's cancel out. So no, that's that same example there of why the 2's go away. All I did was reduce them to 1's. All right, now let's look at silver chloride. Silver is Ag. What's my charge?
1.
Was 1. Chloride is -1. Yep, and so we're going to swap and drop. AgCl. Do I need to write the 1's?
No.
No.
Crushing.
So AgCl.
How
Great
come-
job.
Is that all?
That's not the full lesson, but that's for this part. That's going to name the formula.
That was easy.
Is the full lesson, did it end at covalent bonds? Do you have one more
Nope.
page?
It's just formula to name. The rest of this page.
Yes, we have this last page.
Yes. All right. So name the formula is pretty easy, right? Same exact thing we've been doing for 2 days. So now we're going to go formula to name. It's also easy, but we got to add a little bit of math in there. Because do we know which transition metal we're dealing with? Do I know the charge of it? No, but can I calculate it, do you think?
Yes.
Yes. All right, so remember, transition metals, their charges can change. So if you're dealing with, I'm going to flip back real quick. If you're dealing with AgCl and that's all you have, and you're like, you tell a scientist, oh, I have silver chloride, and you don't put the Roman numeral, do they know what silver you dealt with? No. All right, so you must have a Roman numeral in there. So we need to figure out what Roman numeral to put. So charges change since we know the overall compound must be neutral, right? I have a cation and an anion. And the amount of positivity in order to be neutral needs to equal the amount of negativity, yes. So that way we can always calculate the charge of our cation. So let's go over here and look. Here's your steps. Think transition metal. Transition starts with a A T, yes. So we're going to draw a
T-chart.
T chart. Transition metal, T chart. Those are your reminder keys there. Write out your symbols. Calculate the charge of the one you know. What do you know the charge of? Not the metal, but the non-metal, which is negative, your anion. And we can use that to set it equal to our cation and calculate the charge. Right now, you're probably like, what in the world is this? We're going to do some examples once you get your steps to look back at. So same exact naming rules. Just plop down the name of the cation, change the ending to I on your anion, but what's got to go in the middle? That Roman numeral. So here's an example. First thing, we need to split it up into ions. So the cation is Fe, and the anion is
Please tell me I'm
O3.
doing two column proofs.
No.
I have to do this right
No,
now.
this is not some PTSD on proofs. All right, this is a T chart. This is not a proof. So here's your T. Look, it's a red T. So Fe goes on one side, Fe2 because you have 2 irons, and O3 because you have 3 oxygens. All right, over here, which one do I know the charge of? Do I know the charge of iron?
Oh,
No.
The transition metal, right? I don't know the charge. Do I know the charge of oxygen?
Yes.
Yes. So how many oxygens do I have?
3.
3. And each of those oxygens brings what charge to the compound? -2. All right, so you have the number present, all right? This is the number of oxygens that you have, and this is their charge. So it contributes a total of what charge?
6.
-6. So if the amount of negativity that's brought to you by oxygen is -6, what do I have to have to balance it out? +6, equal but opposite. Don't overthink it, all right? So I need to find out what that charge was. How many irons do I have?
2.
2 times the charge should give me a total of a +6 charge. Well, how do we solve for x?
Divide.
So x equals 3.
Like 4th grade algebra.
Yes, basic algebra.
Why do you need this?
All right, good question. So here we calculated our charge of the anion. And then we needed to set it equal to +6 because if it was contributing a -6, so the amount of negativity that comes from your anion is -6, right? It needed to gain 6 electrons. So that means I needed to get rid of 6 electrons to make it neutral. Remember, it needs to be neutral, so the amount of negativity needs to equal the amount of positivity. All right, so we found out that our charge is 3. So my name is iron. Look, it's color coded for you. Iron oxide, but what do we need to plop in the middle? The Roman numeral. Because if you just tell a scientist, hey, I've got iron oxide here, they're gonna be like, okay, what iron are you working with? Right? They don't know how to duplicate your experiment because they don't know what you were dealing with. So iron 3 oxide.
How would you put that in on like the bomb?
Capital I's. Good question. If when you're doing this online for your assignments, it's a capital I. If you put an L, it's going to be wrong. Dealing with SnO3 now. What is Sn? The cation. What is O3? Your anion. Yep, good job. So separate it out. Always know the charge of the right side, right? So how many oxygens do I have? 3, and it's not always oxygens. These 2 examples just happen to both have oxygen. All right, and what's the charge of oxygen? -2, which equals a total of -6. So I'm going to set this side equal to 6 because they need to cancel out. How many 10s do I have? 10 is in like 10 foil, SN, not 1 0. 1, and then I need to find the charge. Well, what does x equal? 6. Yes, x equals 6.
Wait, will the 3 always be given to you, like that number?
Yeah, you'll always know how many you have. That's what your subscripts tell you.
Get to 880 for the second one?
Yes. That's your charges. Same thing you've been doing. So here it is in steps. Got my 6. So now what do I have?
10 oxygen, 10, 6 oxygen.
10, 6 oxide. It tells you what 10 you're working
What's
with.
oxide?
Oxide. Remember, change your ending to I.
Yep.
Keep that first syllable, change it to I.
Technically, it is.
Yes, we're gonna do them together.
No.
We'll do the practice ones with polyatomics. Y'all got the basic ones?
Yes,
All right.
got it. Done.
Let's go to polyatomics.
What? Where are these?
They're not there. You can just like mark one out and replace it with a polyatomic. You all only have the simple ones, not the.
Oh.
Yep.
Oh.
Start with lead carbonate. How many carbonates do I have?
2.
2. All right, because this right here is my package, and I'm looking at how many packages inside the package. I have 1 cookie and 3 Oreos, and I have 2 baggies of snacks.
That's
Okay.
a great package right
So there we go. Thank you. All right. Look on your polyatomic list. What is the charge of CO3?
there. 7. Wait, no.
Polyatomic list.
-2.
-2. So I have a total negative charge of -4. So what does my other side need to equal?
4.
+4. All right. How many do I have? Only 1. So what does X equal?
4.
So the name of this is PB, which is,
Lead.
what's my Roman numeral? 4 IV, yep. And then carbonate. All right, make sense?
I think we should be done.
Questions?
I think
No.
it's-
All right,